Linked servers and replication. In this nugget, we're going to start by talking about linked servers, which are a way for SQL Server to incorporate data that lives in other places. Then we'll talk about SQL Server replication, including the types of replication, how to set it up, some of the caveats around replication, how to partition your data for different replication scenarios, and how to monitor replication to make sure it's working perfectly. First up, let's talk about linked servers. Now, most enterprises have got data living all over the place. You've got data in Excel spreadsheets, data in Access files, data sitting on MySQL database servers, SQL Server servers, Oracle servers, whatever else. A linked server is a way to point SQL Server to another type of data so that someone developing for SQL Server, writing queries or whatever, can query that data as if it were local. So it makes all those remote forms of data look as if they actually live on SQL Server. And SQL Server takes care of sort of bridging the gap and making them look connected. So let's open up Management Studio. We'll connect to our database engine. And these things all live under Server Objects Linked Servers. Now you can see that I've created one called Other Server, and if I open it, I can browse its databases, including my default database. Now there's a little bit of fanciness that has to go on with security and all that. So the first thing you're probably going to need most of the time is a connection string that tells SQL Server how to connect to the remote data. Now the first thing in order to have a connection string is that you need a provider. Think of this as a database driver. Jet here handles Microsoft Access. This is for SQL Server native client, and so forth. So if, for example, I needed to connect to an Oracle server, I'm going to have to install the Oracle provider or database driver on my SQL Server first. That gives SQL Server the program code it needs to talk to that particular brand of database product. Once that's done, I need to develop a connection string that contains the actual instructions for connecting to the database. SQL Management Studio does not do a good job of this. Here's what I like to do. Go to New, create a new text file. Name it whatever you want, but change the .txt file name extension to .udl. And then right-click it and tell it to open with OLADB Core Services rather than Notepad. Start on the Provider tab, tell it what type of database you're going to connect to. I'm going to connect to another SQL Server, let's say. I'll click Next, put the server name in, we'll call it Nuggets1 App1, that's a specific instance. I'll tell it I want to use integrated security, or you could put a username and a password. For linked servers, this is usually better than integrated security. Because at the time SQL Server is making the connection, your integrated security credentials won't be available. You'll usually want to specify a username and a password. Then you can select a database that you want the connection to go to, test the connection, good it succeeded, and save it. Then open this file in Notepad and simply copy that connection string to the clipboard. Then we don't need that anymore. We can go back here and create a new linked server. Give the linked server a name. Another server. Doesn't matter. Inside SQL Server, that is going to look like the server name. So that's what a developer using SQL Server would actually try to talk to, is another server. Tell it the provider you selected, and then just paste in the provider string. From there, you can configure security options and server options. Server options, by and large, you don't need to change. If you do, then it's going to be on a kind of a per product basis, and you're going to have to talk to or work with the other database product manufacturer to find out how these things have to be set up. On the security tab, though, here's something interesting you can do. You can map local logins, like Dave, to remote user accounts. You've got two options. I can say that when Dave on my server attempts to use this linked server, I want to pass his login credential across the network to the linked server because I've already created a login named Dave there, and it has the same password, so the two will match up. Or you can say that when Dave on my server tries to use the linked server, I want him to look like Joe with this password on the remote server. So when Dave uses my server and he attempts to go across the linked server connection, the linked SQL Server will log into the linked server as Joe using this password. Now you can say, If anyone other than Dave, in other words, for a login not defined in the list above, if anyone other than Dave tries to use this linked server, don't make the connection. Or make them anonymous. Or just pass along their current security context, or use this default. We'll just call it nobody and put a password in. So this helps you determine how the security credentials on your server are passed across to the linked server. Once the linked server is set up, that's really all you need to do with it. It's the developers, the people who are running queries, who are going to be utilizing the linked server. You're not really going to monitor it or anything else. So that's how to sort of set all that up. Now let's talk about replication, which is another way SQL Server has of distributing data throughout the environment. SQL Server's replication model basically looks like this. You have a source for your data, and this is called the publisher. And then you have one or more targets for your data, places that you want the data to be replicated to. And these are called subscribers. There are many different types of replication, but they all involve pushing data from the publisher to the subscribers. And you don't need to replicate an entire database. Remember, within a database, that'll be the database, you've got multiple tables. So each table can become an article in a replication publication. So the publisher publishes publications. A publication consists of one or more articles or tables, and that's what a subscriber actually subscribes to. Now SQL Server's got a few different types of replication to work with. One is called snapshot replication. The next is called transactional replication. And there's another type called merge replication. The differences between these are kind of based on how they work. A snapshot replication is more or less exactly what it sounds like. You start with a pure copy of the published data, and you periodically update that copy and send along the differences. Transactional replication doesn't replicate the data. Instead, it grabs transactions as they're coming into the transaction log and replicates those transactions. The recipients, the subscribers, replay those transactions to recreate new data, changes to data, deleted data, and so forth. Merge data is kind of a special situation we'll talk about in a second. But the basic differences between these is as you go further up this line towards snapshot, you get a bigger latency, more latency, meaning the data on the subscribers has the opportunity to be more out of date because snapshots only occur on a periodic basis, not a constant basis. The lower on the scale you get, the lower the latency is, and the more the data is being replicated across, but the more traffic and the more workload you're putting onto the system. Now, most SQL Server replication is one way. That literally means you go from the publisher to the subscribers, and that's it. What you can do is tell the subscriber, hey, you're also a publisher, and tell the publisher, hey, you're also a subscriber. And that creates two-way data replication. Now, you can imagine that this has a number of opportunities for data collisions and data to be overwritten. Understand that SQL Server doesn't have anything to do with resolving those issues. Let's take a look at how this might work. Let's say I've got a publisher and a subscriber. So we'll put P down here for pub and S for subscriber, and the replication goes that way. And let's say we're doing transactional replication. So as transaction A gets put into the log, it's copied over to the subscriber who repeats A. If we were to set this up as sort of a two-way, so that both of them are publishers and both subscribers to the same articles, it knows that this A came from a subscription and it won't try to replicate it back. But if someone else tries to change that exact same data a microsecond after this gets there, then that'll be replicated over, and the person on this end might be a little bit upset about having their data overwritten. It gets a little trickier though because transactional replication is not instantaneous. It's possible for a transaction to go into this log and before replication actually occurs, for a transaction to go into this log. And it's really almost random as to which one winds up hitting first or second, and you can wind up with data that's not exactly out of sync, but certainly not what you expected. So that type of replication is really intended for one-way use. Merge replication is designed for each person in the configuration to be both a publisher and a subscriber, and they literally merge changes with each other. Now, it's still possible for data collisions to occur, and in order to deal with those, you write something called a merge handler. This is something that actually has to be written. It gets bundled into a DLL and installed on SQL Server and everything else. It's very official. But there's a default merge handler which basically just says the most recent change based on its timestamp wins. Now, you might want to have your developers write a merge handler that says, well, everybody's allowed to update data, but this particular server is the master server, and that's the one that's always going to be correct. So if there's a data collision, take its data as the data that wins, and if the replication doesn't involve this server, then you can take a timestamp. So a merge handler is basically a way of you setting up custom rules for dealing with merges. So let's take a look now at how replication actually looks in the product. Actually, you know what, before we do that, let's talk about some architectural issues. First of all, when you've got a publisher and you've got many different subscribers, you can run into a situation where the publisher is spending so much effort pushing data out to subscribers that it becomes a real workload impact. So you can have a middleman called a distributor. Essentially, it's a special type of subscriber. The publication articles are put onto the distributor and replicated out to the subscribers from there. The distributor is optional. It's perfectly legitimate to have the publisher be the distributor too. It's simply a matter of configuring the workload. And one of the things you need to understand is when we start replication, the first thing you always have to do is make sure that the publisher databases and any subscriber databases are in perfect synchronization with one another. Typically, the way that happens is by starting the process with a snapshot replication, a one-time snapshot replication, after which you kick in your either regular snapshots or your transactional or your merge replication. So now that we've kind of got that architecture out of the way, we're ready to look at what this looks like in SQL Server. So let's start by getting SQL Management Studio up and running and connecting to our publisher's database engine. Alright, and here's our databases. Now you might think that you would right-click the database you want, like my database, and pick Replicate on here. But actually, there's a separate object under here for replication. And what we're going to do is create a new local subscription, new local publication rather. So first thing we have to do is decide where this publication will be distributed. We can either use a server that has been configured as a distributor, or we can say that this server will act as its own distributor, in which case this machine will be configured for distribution. That involves creating a separate database where distributed articles will be published. Now let's say you have a SQL Server sitting in the middle somewhere and you just want it to be a distributor. Go to Replication, click on and configure distribution. That way you'll create the necessary distribution database. But we're just going to create a new publication and say that this server will be its own distributor. We have to decide where snapshots are going to go. And typically the path that it suggests is fine, provided you're going to have plenty of space there. You must use a network path to refer to the snapshot folder. So in other words, to allow distribution and merge agents on subscribers to get to these snapshots, this network path has to be on a snapshot folder. Now what it's telling me here is that this snapshot folder does not support pull subscriptions created at the subscriber because it is not a network path. So it's okay for me to write this here, but really what I want to do is create a network place for these things to live. So let's do that. First of all, let's make sure we know what our computer name is. Okay, our computer name is Nuggets1, and let's just go onto the computer, into the C drive, create a new folder called REPL, and then we will share this. We'll share it as REPL. And of course you never want to do this, but I am going to make sure that this is set as everyone full control, just to make things a little bit easier on myself. So we'll let the administrator be the owner, and we'll share that out. And now I'm actually going to go modify the properties of that sharing tab and set up some custom permissions. We are going to add the everyone group and give it full control, just to the share. And then we also need to make sure that the security is going to allow everyone else to read it. So just to, again, shortcut the process here, I'm going to add everyone and give him full control. You don't need to do that in a real environment. In a real environment, SQL Server is what's reading it. So whatever account it's running under is what's going to need permission to read and potentially write to this folder and the shared folder. In a lab environment like this one, giving everyone full control is just sort of a way to bypass the NTFS permissions and get moving a little more quickly. Alright, so now let's try creating a new publication again. We are going to put this in Nugget 1 REPL. Let's just double check that computer name, because I always mistype that. Nuggets 1. See, I'm glad I checked that. Nuggets 1 REPL. Okay, so what database are we going to publish? Let's publish my database. What type of publication? We can choose to do snapshot publication, transactional publication, a transactional publication with updatable subscriptions. And that's kind of the idea of I'm going to publish, but my subscribers are allowed to send updates to me. Or I can do merge replication. Let's start with transactional. And incidentally, there's a great breakdown of all the different differences between these and how they work and everything else. Alright, so what tables do I want to put into the publication? Well, there's only one, so I'll just put that. And I'm going to set the properties of all table articles. So do I want to copy foreign key constraints? Do I want to copy any clustered indexes? Your developers are going to have to help you understand what data needs to be replicated in order for their application to work, because all of this is absolutely application dependent. So let's move on. I do not want to filter any of the data in my publication. In other words, I want to publish all of the data that's in those tables, so I don't need to add a filter. Now, snapshot agent. How do I want to do this? Do I want to create my initial snapshot now and then keep it available to initialize future subscriptions? Or do I want to have a snapshot agent scheduled to run at specific times to create new snapshots? Or I can do both. We're going to create a snapshot immediately. And I need to specify a login for the replication agent. So we're going to run it under Nugget Lab administrator and provide the password. Or I can run it under the SQL Server agent service account. And the reason that's not a recommended security best practice is because the SQL Server agent account is also capable of doing so much else. It's really better to set up a dedicated account just for replication. So let's try that. Okay. Now we're going to create the publication. We need to give it a name, so this is going to be called MyPub. We'll click Finish, and that will start the creation of the publication. Okay, I did pause the recording. That actually took about 10 minutes to run on my virtual machine here. So I configured the distributor, I created the publication, added its article, and then started the snapshot agent. So this is now being published. Once we've done that, and we don't have any subscribers yet, so this might not be super interesting, but we can launch the replication monitor. This is how you keep track of what's going on in replication. Looks like this particular publication is okay, and that's good to know. We can see that there are no subscriptions, but also no warnings, which is fun. All right, so now let's create a subscription for this. To do that, I'm going to connect to another database engine instance and come down under replication and create a local subscription. Okay, so who is the publisher? Well, the publisher is Nuggets 1 by itself. And there's the publication, MyPub. Now, how do I want to do this? For subscriptions I create in this wizard, do I want to run all agents at the distributor, which means Nuggets 1 is going to be pushing information to me, or do I want to run the agent at each subscriber, meaning each subscriber is going to contact the distributor on their own and pull? It reduces processing overhead at the distributor, and it kind of spreads the workload out across all the different subscribers. It also lets the subscribers administer synchronization, but it means that synchronization has to be administered at each subscriber. So it does make it a little bit more difficult to centrally manage everything. I'm going to just run a pull subscription here. And this is going to go, I need to really create the database first. If you didn't create it, you can go ahead and select New Database. But this is going to go to the My Database database. And I need to specify security information for all subscriptions before continuing. So let's go ahead and set this. This is going to run under Nugget Lab Administrator. And honestly, the most important thing about selecting replication accounts is you want all the publishers and all the subscribers using the same accounts. That way everybody has all the right permission to all the right stuff. And so that should be enough. So we'll click Next. When do we want this agent to run? Well, let's run it continuously. That doesn't mean it's going to run in real time, but we'll definitely let it run as often as it wants to. And when do we want to initialize that subscription? Let's do it right this very minute. So when this is finished, we're going to create the subscription, and we will see how it goes. So let's get it started. Okay, it just took about 5 minutes, and the subscription has been created. So now we can go back to the replication monitor on the publisher. Let's view that replication monitor, and we'll look at the pub here. And we can see that there is a subscription to Nuggets 1 App 1, and it is currently running, and the last synchronization took place then. Here are our agents. Looks like our snapshot agent completed, and we don't have any outstanding warnings that we need to be alerted on. So this is a healthy publication and subscription. So this replication monitor is a great way to monitor replication and make sure that you know what's going on inside of it. Okay, now let's start talking about caveats. We've got different types of replication, and there's a lot of interactions with different SQL Server features. For example, if you are using log shipping, log shipping is completely compatible with replication, except that if you fail over to your standby server, replication stops. Now, if you've permanently lost your primary, what you can do is reconfigure so that your secondary has been renamed to be your primary, in effect, and then you can get replication regoing again. So log shipping compatible. Another feature is database mirroring. This is also compatible with replication. Yay! The trick is only on the publisher. So only the publisher can be doing database mirroring. And in that case, if there's a failover on the publisher, replication will continue working on the failover publisher. But if a subscriber is participating in database mirroring, and the subscriber fails, and it fails over to its mirror, then the mirror will not continue being a subscriber. You would have to manually reset that up. So another issue is if you're using snapshot replication, you cannot do this with databases that are enabled for the file stream data type. That information is not pulled in. And that's because, remember, file streams aren't stored in the database. They're stored in separate files on the disk. The snapshot replication is just grabbing the database. It is not going to go out and grab those other files. It is okay, so let's say no file stream. File stream is okay with transactional and with merge replication, because both of those are working off of information in the transaction log that's used to actually recreate it. So on the subscribers, they would be receiving the transactions, and they would be recreating on their own the same file stream files. So those are some of the caveats about replication that you need to be aware of. Now, there are some techniques that you can use to make replication a little bit more powerful, techniques that can help prevent data collisions and so forth. The main technique you're going to focus on is horizontal or vertical partitioning. So to kind of explain how this works, let me draw a grid which is going to represent the contents of our tables. We've got all these different columns here, column A, B, C, and D, that have our data. And then we've got different rows. Now remember when we set up that replication that we were able to set up a filter. So one trick is to say row D is going to be our partition. We're going to partition this table on this column, which means the values in this column will partition the table. This is referred to as vertical partitioning. Here's why it's called vertical partitioning. Let's say I've got two different copies of my database, and one of them is in the New York location and the other is in the Tokyo location. So in column D, when someone creates a new row, I'm going to put a little indicator in here to indicate where this row was created. So you can see that I'm creating a subset. So this row, this row, this row, and this row all came from New York, and these two rows came from Tokyo. So I've vertically partitioned the table. I've created a vertical partition from New York and a vertical partition from Tokyo. On the New York server, I only publish the rows of data that came from the New York server. And on the Tokyo server, I filter the publication so that it publishes these rows. So basically, the Tokyo server is going to subscribe, so the Tokyo subscribes to this, 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 and this. It's subscribing to the data that was created in New York. The New York server subscribes to this one and this one, which means it's subscribing to the data that was created in Tokyo. So both servers start out with an identical copy of the data. They both publish only new rows that were created on them. And they do that by looking at the contents of this column in the publication filter. The other server subscribes to everything, but the only thing in the publication is the data that was created on the other server. So this is also a good technique for scaling out SQL Server. So now let's take a look at horizontal partitioning. It's a little bit different, but let's say I still have the same grid. And I've got all my different rows. Column A, column B, column C. The other type of partitioning, vertical partitioning, says that the New York server, for example, is only going to publish these two columns, and the Tokyo server is only going to publish that column. And that way you're spreading the data out across multiple servers, and each server publishes the data it holds. The other server subscribes to the data. So the New York server, let's do this in blue, New York server is publishing what's in blue, Tokyo is publishing what's in green. New York subscribes to the green data, giving New York a complete copy of the data, although that data is only supposed to be updated in Tokyo, and then Tokyo subscribes to the blue data. Again, it really depends on your exact business scenario as to which of these you're going to use or whether even either of those is appropriate for you. This isn't a perfect solution for every situation. It's just one way to partition your data out, to segment your data out, to break your data down so that you can have a large chain of replication going around without having data stomping on one another all the time. In this nugget, we talked about linked servers and how they can be used to bring data from multiple locations and make it look like it all lives on SQL Server. We also talked about replication, including the types of replication: snapshot, transactional, and merge replication. We looked at setting up a snapshot replication, including setting up a distributor. We talked about some of the caveats of replication and how it interoperates with other SQL Server 2008 features. We talked about vertical and horizontal partitioning of data, and we looked at the SQL Server Replication Monitor, which is how you monitor replication to make sure it's working perfectly and get yourself alerted to any problems that go on. Don't forget, of course, that you can also use performance monitor counters to keep a track of the progress of replication, as well as things like replication traffic amounts and everything else. I hope this has been informative for you, and I'd like to thank you for viewing.